All right, so we have talked about parallel lines and a little bit about planes way back in chapter 1. So we're going to kind of investigate these a little bit further. So I don't know if you recall this, but we have, if you talk about two separate lines, okay? So two very different lines. We're not talking about putting one line, like drawing one line right on top of another. That's not what we call distinct lines. Distinct lines are literally going to be, here we go, two actually separate lines, like my blue and my orange. So yes, is it possible to draw one line right on top of another one? Of course you could, but then they are essentially the same line. So when we say distinct, we're not counting that scenario. So what I want to talk about is what could these two lines be to each other? There's really only three options. Okay, if they're not going to be the exact same line one on top of another, which they're not, there's only three things that could happen with these two lines. So we're going to take a look at what those are. So two distinct lines. So distinct, remember, is what that term that we're using to say, hey, you're not just drawing the same line on top of itself. These are two distinct or separate lines. Not right on top of each other. So that's what we mean when we say distinct, and we're talking about lines. So two distinct lines must be one of the following. Can't be more than one. There's no overlap here. It's got to be one of the following things. Okay? Two separate lines could intersect each other. Intersect literally just means that they cross each other somewhere. Okay? So there would be two lines that intersect each other. Could they be perpendicular to each other? Sure, they could. Perpendicular is just a special type of lines that intersect that just happen to form 90-degree angles. They're still intersecting, right? So these lines, no matter kind of how I position this, those are still intersecting lines, okay? So that is an option where two lines that are not the same line are drawn and they do cross each other, and they'll notice they'll only do it at one point, right? They don't ever cross twice. 1 point and 1 point only. Okay, so they might intersect. So they can be perpendicular, but don't have to be. Do two lines have to intersect? No, they don't. They absolutely do not have to, because we also have this scenario, right? Where they don't ever cross each other. They just go on forever and ever and ever and ever and ever and ever, and they never cross. But you need to be careful because we've talked about this. They have to lie in the same plane. And if they do, what is the word that we use to describe these two lines? Yes, parallel. So if two lines do not intersect, they might be parallel. So remember what that word meant. It was coplanar lines that do not intersect. There is yet a third option. Does anybody remember what else two lines can be besides intersecting in parallel? There was one more term that we had learned.
Vertical?
Ooh, good guess, but no. This one starts with an S.
Oh, symmetric?
No. It's a four-letter word, starts with S. Anybody remember? Two lines. Here, I'll show you what they look like. if you start with two lines that are parallel, for example, but then you take one of them and you literally pick it up. Do you remember these? So these two lines, everybody look at this at my screen here. These two lines don't cross each other, right? The orange one that's flat on my paper, and then I took the blue one here, and now it's just sticking up like this. If these lines kept going forever and ever and ever and ever, so this one's just going to keep going up and down kind of like this, and the orange one goes this way forever, they're never going to cross. So they're not intersecting, but these are not parallel lines anymore. These were parallel lines, right? They have to lie in the same plane. They have to be flat down together. So if I took one of these and I literally just picked it up off the page a bit, right? You can I highly recommend that you try this, all of you. Just take two pencils or pens or whatever, or a lollipop stick and a pencil, who cares? Put them, make them parallel flat on your desk, and then just literally just pick one of them up. What are these kinds of lines called? They don't cross and they're not parallel. What was the name? Anybody remember? You send it to me in the chat. Shout it out. Starts with an S, 4 letters. No. It was called Skew. Remember that? S-K-E-W. Skew. These are the lines that also do not intersect. Oops, also do not intersect, but are not in the same plane. Okay, so again, easiest way for you to visualize skew lines. Put two pencils on your desk, pick one of them up, stick it straight up and down, just like that. Okay, you will see that they don't cross. They're not in the same plane. That's called skew. All right, so now I'm going to attempt to draw us a cube, and then we're going to talk about some planes, okay? This was all lines. Let's talk planes now. Let me draw you the cube as best I can. It's a little wonky, but hopefully you can. Let me see if I can. This back corner is just bad. Hold on. See if I can just fix this a little bit. That's better. Maybe? I don't know. All right, let's give it some letters. All right, so I have a cube here. Let me zoom in on it a bit. All right, so we can talk about the different parts of this box using our geometric vocab that we have so far. Okay, so I know, for example, that this is just a line segment between A and G. But if I say line, I mean, I want you to visualize as if that were a line. So if it just kept going forever, all right? You can talk about it as segments too. It doesn't really matter. But let me ask you a couple of questions just about the lines here, and then we'll move on to planes, okay? I'm going to ask, let me get your popsicle sticks. So please make sure that you are ready to answer me. We'll start off easy, and then we'll work our way up. Okay, so if I'm just talking about lines right now, Jay, tell me about line AG, so this one here, and line DF. Are they intersecting, parallel, or skew?
Parallel.
Did you say parallel?
Yes.
Yes, I agree with you. Okay, how about Anthony? What are lines AG and GF? Are they parallel, intersecting, or skew?
Intersecting.
Yeah, they intersect each other right here at point G, right? If they cross at any point, they have to be intersecting. Good. Okay, let's see who gets to go next. Ryan, next one is yours. What is the deal with AG and CD? Are they intersecting, parallel, or skew?
Skew.
Yes, those are skewed. Does everybody see that? Look at AG. If you imagine this just shot up in the air and went down here and just went on forever and ever and ever, and then you had this side of the box, right? If you actually envision an Amazon box on your desk and you trace this edge and this edge, they're never going to cross each other. Even if this goes on forever and this goes on forever, they're not meeting each other. Because remember, you got to envision that this is three-dimensional. They don't cross, so they would be skew. Absolutely. All right. Let's see who gets to go next. Evan, how about AD and BC? Are they intersecting, parallel, or skew?
Say it again.
AD, so this one here, and BC. Are those two lines intersecting, parallel, or skew?
Parallel.
Yes, they are parallel. They're in the same plane, the top of the box. They never cross. All right, Marissa, do you want a trick question or no?
I don't really care.
All right, let's go for it then. How about AG and CE?
Are they like, they're not congruent, but they are.
So you're going to choose between intersecting, parallel, or skew.
Are they parallel?
Yes. So a lot of times kids won't think that the corners here, or these side corner edges, AG and CE, they are parallel. And here's what's confusing about this. It's very obvious that AG and DF are parallel, right? Because they're both on the front of the box. So everybody's like, yeah, they're in the same plane for sure. Here's the thing though, AG and CE are in the same plane. It's just not one of the planes that's drawn as part of the box. But couldn't you imagine that I took a piece of cardboard or something and I stuck it in diagonally? And wouldn't it contain both of those edges? Right? I wish I had maybe I'll start collecting my Amazon boxes and show you how you can put them together. But yes, they are in the same plane. There is a plane that contains line AG and CE. It's just not drawn. But remember, we don't care if it's drawn or not. The question is, could you draw it? And you could. Yes. Oh, good. All right. Let's see. Who gets to go next? Zoe. All right, Zoe. What is the deal with line HG and line DF? Are they intersecting, parallel, or skew? Zoe says skew. She's right. Yes. You have these two edges. They're never going to meet. Right? If you follow along this and you follow along this, they do not ever cross. Okay, one more before we start talking about planes. Will, can you tell me about AD and DF? Are they intersecting, parallel, or skew?
Wait, say it again.
Line AD and DF, are they intersecting, parallel, or skew?
Intersect.
Yes, and they intersect right here at point D. Perfect. Okay, now let's switch our conversation to planes. So if you remember, planes are the entire surface, right? So we think about planes, okay, you can think about it like the top of this box, right? But it doesn't actually stop here. It goes on forever. So we don't really have things in the physical world that do this. So you just want to imagine that this surface, if you were to just make it go expand forever and ever and ever and ever and ever, that would represent a plane. So there's another plane represented by the front of the box. You have another plane represented by the bottom of the box. So to name planes, if you've forgotten, all you need is 3 letters that are on the plane. Okay, just make sure that they're not all 3 in a line, but I don't think we have any of there's none in this picture that are all 3 in a line anyway, so we don't have to worry about that. So what can planes be? I just told you that 2 lines have to be either intersecting, parallel, or skew. That's it. You only have those 3 options, and every pair of lines falls into one of those 3 categories as long as they're actually 2 separate lines. What's the deal with planes, though? So, could 2 planes intersect each other? Let's start with that. Could I have intersecting planes? What do you guys think? Someone tell me. Can 2 planes intersect each other? You know this because you even know what they intersect at. I guess I just gave you the answer. Yes, 2 planes can intersect each other. So let's go ahead and jot this down. 2 distinct planes. So again, I'm talking about 2 separate planes, not one plane literally right on top of another. So 2 distinct planes can be intersecting. Oh, I'm sorry. I didn't realize I was off the screen a little bit. There we go. So if you have 2 separate planes, they can intersect each other. If they do intersect each other, remember from, can't remember if that was chapter 1 or chapter 2. If 2 planes intersecting each other, they do so in a line. Remember that? So I'm just going to add that. If 2 planes intersect, they do so at a line. All right, so if I have 2 planes, they can intersect each other. Do 2 planes have to intersect each other? That's my next question. If you have 2 separate planes, do they have to intersect? What do you guys think? The answer is no. They don't have to. If you think about the floor that your feet are on right now, if you imagine that as a plane, right? Imagine that surface just goes on forever and ever and ever and ever and ever, okay? And then you have a ceiling up above you. If that ceiling were to go on forever and ever and ever and ever, those are parallel planes. They're never going to meet each other. They never meet. You might have walls that intersect them both, but where does the ceiling meet the floor? It doesn't. Right? So yeah, it's absolutely possible to have parallel planes. We have them all over the place. Parallel planes, definitely possible. I like to think about it as sliced bread, right? Each slice is parallel to the next one. They're all parallel planes. All right, so 2 distinct planes can be intersecting or they can be parallel. Now, lines have 3 options. They can be intersecting, parallel, or skew. Do planes work the same way? That's a great question. And the answer is no. There is no such thing as skew planes. I know what you're thinking. Well, why not? Why couldn't you have them? So I'm going to do my best to show you an example. Let me get some of my Post-it notes here. All right, so here's what I want you to do. I don't have two post-it notes of the same size for some reason, but that's okay. So I have my two post-it notes. Imagine that they're each a plane. So imagine this gold colored one just is a surface that goes on forever and ever and ever. Same thing with this blue one. It goes on forever and ever and ever. Now, if you remember with lines, for me to make them skew, what I did was I started with them as parallel, and then I just pick one of them up and turn it so they're not in the same plane anymore. Okay, so let me try to do the same thing with my planes. I'm going to start with them parallel, and then I'm just going to turn one of them. See if I can do the same thing. So here's my two. So I'll start with them parallel. So I don't know if it is kind of hard for me to show you, but let's try it this way. It's actually worse that they're sticky. All right, so here they are, parallel to each other. If I try and just turn this one, remember that it never ends, so it's going to crash right into this one. So then they would become intersecting. All right, well, what if I tried to turn it a different way? If I turn it like this, they're still just parallel. So I haven't, it's still not skew. They're just parallel, more parallel, more parallel. So I could turn it this way, it crashes in. The only other way I guess I could turn it would be this way. Yeah, there is no such thing as skew. You can't get there with planes because they go on forever. So eventually, they're going to crash right in. So the only options for planes is that they are either going to intersect each other or be parallel. You don't get a third choice. Okay, does this make sense so far? Is everybody with me? So let's go ahead and add that. I'm going to put a star here. No such thing as skew planes. No such thing as skew planes. It's impossible. They're only going to be parallel or intersecting. All right. So, the next thing I wanted to do, that's actually all that I wanted to write down for notes because the rest of it, you kind of just have to see it. So I'm going to hop on over to Delta, and I thought that we could just do, I have a couple of practice problems. So let me switch to that. Let me stop this. And let's see here. Yes, okay, so let me just share this. Let me zoom in a bit. Okay, so the question that they're asking, oh, you know what? Let me get in on my iPad too so I can draw on this. Jeez. Oh. Okay, so this one, they are asking you about RN and OS. So let me just go in and highlight those two. Oh, where's the highlighter tool? Is there one? I know I usually, what the heck? Oh yeah, there it is, highlighter. Okay, RN and OS. Okay, so if you had to pick from this drop-down menu, oh, you can't see them. Shoot. Gotta zoom out a little. Sorry. I thought you'd be able to see them all. It's only parallel, perpendicular, and skew. So what are these two to each other? RN and OS. Let's see who gets this one. Lily is not here, so she can't answer, but Michael can. Michael, what are these two?
Parallel.
Yes, parallel. Okay. All right. So here they want name two segments drawn on the diagram that are parallel. Okay, so you get to pick any two that you want. Tom, can you give me two parallel segments here?
PL and QM.
Yes, PL and QM. Those would work. QM. Lovely. All right, let's see what else we got. Planes. They want two planes that are parallel now. So let's see how we do with this. Jeremy, you get to go. Give me two parallel planes here.
O, P, and RQ.
ORQ, is that what you said?
Wait, no. OP, RQ.
Oh, okay. You only need 3 letters.
Okay.
So let's do OPQ. And then what other one?
KLM.
KLM. That looks good to me. And what I like about this, watch when you submit these things, look how it shows you the planes that you were talking about. Isn't that neat? So unfortunately on your homework, I didn't assign you these types of problems. They were just sort of straightforward ones, but I'll give you these at some point, like when we're doing practice. So you can see if you had picked different planes, it would highlight different ones. Whatever ones you said, it'll show you. It's so cool. All right, let's try, what is this one? Ooh, so this one, you just have to tell me what PT and NO are to each other. So here's PT and NO is over here. All right, so what would you do with these two? By the way, everybody has been selected once, so you're all back in it. So what are these two? Evan, what would you say? I think your choices are parallel, perpendicular, or skew. Evan, you there? Evan, this one's yours. Parallel, perpendicular, or skew?
Perpendicular. Right, skew.
Oh, I'm sorry. Yeah, I misspoke. I didn't. Oh, yeah, perpendicular is a choice. But yeah, skew is correct. Skew. By the way, when are you going to pick perpendicular? Good question. So perpendicular is only going to happen when you have two that meet each other at 90-degree angles. So for example, those two would be perpendicular to each other. Would these be perpendicular? This one and this one? Yes, even though I know you're looking at this and you're like, well, that angle doesn't look like it's 90. It does, though, because remember, this is 3 dimensions. That's the corner of a box. When you get an Amazon box, every corner is 90, right? It'd be a very weird box to not have corners of 90. It's possible, but I mean, clearly, and I think they tell you up here that it is, when they say right rectangular prism, that means all of your angles. Yeah, all of the angles shown are 90. So in an example like that, you know that they are all 90s. So, but anyway, yes, Evan was right that PT and NO, that was these two, are going to be skew. Good. Okay, let's see if we can get another one that asks about planes. That's perpendicular. All right, so let's talk about this one. They want to know about plane Jim and plane GHL. So plane Jim, take a look. JIM. So the plane that has those 3 points in it, isn't it this whole side right there? That's how you figure out what plane they're talking about. look at the points that they list, and then what plane contains all of those 3 points. There's only going to be one. So that's that plane. And then let's look at plane GHL. So let me switch colors here. GHL. So here's G, here's H, here's L. Oh, okay. There's only one plane that contains all 3 of those dots, and it's right here. It's this side. So now that we know that we're talking about those two, what are these 2 planes to each other? What are our options? Parallel, perpendicular, and intersecting, but not necessarily perpendicular. Oh, let me zoom down a little bit so you can see them all. There's your 3 choices. Parallel, perpendicular. They intersect, but they're not perpendicular. Okay, so those are the 3 options. What would you say for these 2? Lily's not here, so she can't answer. But Jay, you're here. What are these 2 planes? Are they? Yes, they are parallel. 2 sides of a box like that are always just going to be parallel to each other. Good. All right. Okay, guys. Oh, and see how nice? Look, they even used blue and green like I did. But theirs looks so official. All right. Does anybody have any questions on parallel, perpendicular, skew lines, planes? I'm going to ask you a couple more questions. Let me just make sure that yeah, okay. So the next couple of questions I want to ask you about are what about the meeting points of these things? So let me ask you this. Let's see who gets to go next. Ryan, this one's yours. So tell me, Ryan, where do lines, let me switch over to blue here. Where do lines ST and UT, where do they intersect?
T.
Yes, point T. If you have 2 lines that are going to intersect, they're going to intersect at a point. Okay, how about these? How about SO and ST? Where do those 2 intersect? Jeremy? Yeah, point S. All right, let's get fancier. Let's start talking about planes. All right. So let's say one plane is the right-hand side of the box here. I'll shade it in blue. Okay, so we have that plane. And then let's talk about the other plane that I want to talk about, which is, let's do the top of the box. Okay, where do these 2 planes meet? Michael, can you tell me?
PU.
Yes. What word do you have to put in front of it, though? Is it a point, line, or plane to you?
Line.
Yes, line. Everybody see that? 2 planes will always intersect in a line. So the answer to this question would be line TU or UT, however you want to say it. But you need to say that it's going to be that line. All right. A lot of times kids mess this up. The question is, where do these 2 planes meet? And they say point T. Well, 2 planes intersect in a line, though, so you need to name the entire line. Okay, so just saying T isn't going to cut it. All right, let's do one more like this. Oh, you know what? Actually, put that back. Let's do that plane, and then I'll add on. Oh, how about this plane? Oh, wait. Sorry. No. There we go. All right, where do these 2 planes meet? Anthony.
What 2 planes?
The two that are colored. So you have the bottom one that's green and the right-hand side one that's blue.
I don't know.
Where do they meet?
P?
That's part of it. It's not just at P though. It's this
Well,
whole.
P and the, yeah, the P and the Q. And like the.
So it's going to be line PQ. That's what you're looking for. Yes, two planes will always intersect in a line. So we need to name it as a line PQ or QP, either one. All right. I think that's everything that I actually need to cover for today. I know it's kind of short, right? I want to make sure that I didn't leave anything off. So your homework should already be live for you in Delta. So I'm just going to hop on over there real quick. And let me just pull up your homework and we'll take a look at a few of them. So again, unfortunately, guys, I'm sorry, but for today, it's all going to be the questions that you don't get to keep doing them, right? It's all ones that I had to make. They have, as you can see, they just added quite a bit in this section. So we'll have it to practice later, but they didn't have exactly what I wanted. So I just left it from before. So anyway, you'll click on one and it'll just ask you, are these two segments that I've listed here parallel, skew, or intersecting? Or they'll ask you some variation of this, okay? So FA and ED, for example, if I'm going to do these, let's see. FA is right here. And ED is right here. And I can tell that those are going to be parallel. Those are both in the same plane, but they never intersect each other. So I'm just going to choose parallel from that drop-down menu, and we should be good to go. So I'm going to jump ahead here. Let's try just this one. What's this asking me? Name the plane that is parallel to GHNM. Please use all 4 letters to name the plane. Okay. Oh, I'm glad I picked this one because yes, normally you only need 3 letters to name a plane. You don't need 4. However, I don't know. I guess oh, that's right. I remember because I made this. So the only way to make sure that it'll take it in any order, but you needed all 4 points. I couldn't have like some with 3 and some. It was a mess. So anyway, let's see. Plane GHNM. That's the top of this box. Hopefully you can see that. There's plane GHNM, that top there. So if I want a name who's parallel to that, doesn't it have to be the bottom of this box? Yeah, so when you're naming that bottom plane, yes, I know that normally you only need 3, but you're going to have to use all 4 letters, J-I-L-K. And that should work, and it should work in any order. And you know what? I'm going to try not using, you're supposed to use capital letters, but let's try not using capital letters and see if it takes it. Ooh, it does. So good habit to get into to use capital letters because you're supposed to. But just know that if you don't, it'll take it. Okay. I'll do one more. What's the last one? Ooh, this is a good question. How does AB relate to each of the following? So if I'm looking at AB and I compare it to CD, all right, well, those are definitely in the same plane and they are not intersecting each other. So I would pick parallel. AB compared to EC now. Let's try that. AB, and let's see, where's EC? Over here. Interesting. Well, they're definitely not parallel anymore. So I'll leave it up to you to decide if you think that they are intersecting or skew or not. And then same thing, AB with ED. I can't give you all the answers, but give it your best shot. Does anybody have any questions right now? Okay, I'm going to end the recording.